Deep beneath the warm blue waters of the Pacific lies a world so alien, so crushing, so dark, that for centuries it was thought to be utterly lifeless. A place where bones would dissolve, cells would implode, and life itself would break under the weight of the ocean. Yet, against all odds, creatures live here. Not only do they survive, they thrive. And the secrets they hold could change the future of medicine, climate science, and even our search for life beyond Earth. This is the story of the Mariana Trench, the deepest place on our planet. Stretching in a long crescent across the western Pacific, the Mariana Trench is Earth's final frontier, a gash in the planet's crust nearly 2,500 kilometers long and up to 70 kilometers wide. At its deepest point, the Challenger Deep, the seafloor plunges down almost 11 kilometers beneath the surface. If you dropped Mount Everest into this abyss, its peak would still be nearly 2 kilometers underwater. But this is not just a hole in the seafloor. The trench is a living laboratory of extremes, a place where crushing pressure, freezing temperatures, and eternal darkness forge creatures and ecosystems unlike anything else on Earth. Today, we'll descend together through the layers of the ocean, past strange glowing predators, past the crushing limits of submarines, and down into the black maw of Challenger Deep itself. And along the way, we'll uncover what scientists have found, what remains a mystery, and why the answers hidden here may shape the future of humanity. It begins far from any shore, deep in the western Pacific Ocean, where the blue surface hides a secret world unlike anything else on Earth. Beneath the sunlit waves lies a scar in the planet's crust so vast, so deep, and so extreme that for centuries it was thought to be utterly lifeless. This is the Mariana Trench, the deepest place on Earth, a realm of crushing pressure, eternal darkness, and creatures so bizarre they seem to defy biology itself. The trench stretches in a sweeping arc for more than 2,500 kilometers, longer than the entire United States is wide. At its broadest, it is 70 kilometers across, but its most infamous feature is a single pit within its vast expanse, the Challenger Deep. Here, the seafloor plunges nearly 11 kilometers beneath the surface. To imagine this depth, take Mount Everest, the tallest mountain on Earth, invert it, and drop it into the ocean. Its peak would still lie almost 2 kilometers below the waves. The pressure at this depth is beyond imagination. For every 10 meters you descend into the sea, the weight of the water increases by another atmosphere. By the time you reach the bottom of the Challenger Deep, the pressure is over 1,000 times that at the surface. That means more than 15,000 pounds pressing down on every square inch. Imagine the weight of 50 jumbo jets resting on your body. No human, no whale, no machine built carelessly could withstand it. And yet, life exists here. The first evidence of the trench came not from submarines, but from ropes and lead weights. In 1875, the British ship HMS Challenger was conducting the first true scientific survey of the ocean floor. Day after day, sailors lowered weighted lines into the water, sounding the depths. They expected the bottom to be 3 or 4 kilometers down, typical of the oceans they had already mapped. But east of the Philippines, the rope kept sinking. 4 kilometers, 5, 6. The weight continued to fall into blackness, pulling more rope into the sea. Finally, after hours, it struck bottom. They had discovered a place deeper than any yet recorded, a gash in the crust that would come to be called the Mariana Trench. Decades later, scientists would learn that this trench is no accident of geography. It is the product of plate tectonics, the slow but relentless shifting of Earth's crust. Here, the vast Pacific plate collides with the smaller Philippine plate. The older, heavier Pacific crust is forced downward, sinking back into the mantle in a process called subduction. Over millions of years, this conveyor belt of rock has carved the deepest trench on the planet. Along its walls, there are cliffs taller than the Himalayas, slopes steeper than any canyon on land, and volcanic systems unlike anything else on Earth. Some volcanoes here erupt liquid carbon dioxide instead of gas, kept in that state by the crushing weight of the water. Others contain pools of molten sulfur, a feature found only here and on Jupiter's volcanic moon, Io. But the trench is more than geology. It is also a biological frontier. For generations, scientists believed no creature could live under such intense pressure, in water so cold and utterly without light. The very chemistry of life seemed impossible here. And yet, in 1960, two men proved that theory wrong. On January 23rd of that year, U.S. Navy Lieutenant Don Walsh and Swiss oceanographer Jacques Piccard climbed into a steel sphere called the Trieste. Suspended beneath a massive float filled with gasoline, their vessel resembled a bomb more than a submarine. Its pressure sphere was just over 2 meters in diameter, with walls made of thick steel. The two men squeezed inside, lying shoulder to shoulder in the dark, knowing that as they descended, the pressure outside would rise to 1,000 times that of the surface. For nearly 5 hours, they fell into the abyss. At 9 kilometers down, a loud crack thundered through the vessel. One of the outer window blocks had fractured under the strain. Still, they continued, until finally the Trieste settled onto the floor of the Challenger Deep, 10,916 meters below the surface. Their tiny viewing ports showed a pale sea floor of fine sediment, disturbed by their arrival. And then, movement. A living creature, what they thought was a flatfish, swimming across the bottom. The textbooks had been wrong. Life existed, even at the deepest place on Earth. For half a century, no one returned. The abyss remained untouched, visited only by unmanned probes and sampling devices. In the meantime, thousands of climbers scaled Mount Everest, and 12 astronauts walked on the surface of the moon. But the deepest ocean, right here on Earth, remained nearly unexplored. It wasn't until 2012 that another human descended to the Challenger Deep. This time, it was filmmaker James Cameron in a green submersible called the Deep Sea Challenger. Alone, he spent nearly 3 hours at the bottom, describing a barren plain of silt that looked more like the surface of the moon than any earthly environment. He collected samples of sediment and invertebrates, proving again that the trench was not lifeless, but home to organisms uniquely adapted to its hostile conditions. Since then, a handful of explorers have followed. Victor Vescovo, aboard his titanium submersible limiting factor, made repeated descents beginning in 2019. His expeditions mapped the seafloor in unprecedented detail and filmed strange creatures drifting through the beams of the submersible's lights. Among the discoveries were snailfish, delicate and translucent, living at depths no fish had ever been seen before. Giant amphipods, shrimp-like crustaceans as long as a human hand, were collected and studied. Microbial mats clung to rocks, feeding not on sunlight but on chemistry, thriving in a world that should be barren. What makes these creatures so remarkable is not just that they live, but how they live. The Mariana snailfish, for example, has bones that are softened and flexible, allowing them to withstand pressure that would crush ordinary skeletons. Their cells contain unique compounds that stabilize proteins, keeping them from warping under the weight of the abyss. Amphipods here have adapted in ways equally strange. Because calcium carbonate dissolves under such pressure, they cannot rely on it to build their shells. Instead, they incorporate trace metals from seawater, creating a protective sheath unlike any other animal on Earth. Even the single-celled organisms here defy belief. Xenophyophores, which resemble clumps of mucus or sponges, grow as large as dinner plates, making them among the largest single cells known to science. Each adaptation is a reminder that life will find a way, no matter how hostile the environment. The deeper you descend into the trench, the stranger the ocean becomes. The sunlit waters above, the epipelagic zone, extend only 200 meters down. This thin film of light is where nearly all marine life we know thrives: plankton, tuna, dolphins, sharks. Below this, the twilight zone begins, stretching to 1,000 meters. Here, the light fades into a dim blue haze, too weak for photosynthesis, but still enough for strange creatures to sense. Tiny fish, called bristlemouths, swarm here in numbers so vast that scientists estimate their population in the quadrillions. Each no longer than a finger, they are the most abundant vertebrates on Earth, and yet few people have ever heard of them. Past 1,000 meters, the last rays of the sun vanish completely. This is the midnight zone, a world of total darkness and eternal night. The water temperature hovers just above freezing, and the pressure is already hundreds of times greater than at the surface. Yet this zone is not empty. Instead, it comes alive with light, not from the sun, but from the creatures themselves. Bioluminescence is the language of survival here. The darkness glitters with ghostly flashes and pulses. Tiny plankton emit blue sparks when disturbed. Predators wield glowing lures like bait. Prey confuse their hunters with dazzling bursts of light. The anglerfish, perhaps the most iconic creature of the deep, drifts through the darkness with a luminous lure dangling from its forehead, wriggling like a worm. When a smaller fish swims in to investigate, the anglerfish's jaws snap shut with terrifying speed, trapping the victim in a mouth filled with long, needle-like teeth. Other creatures here are just as strange. The barrel-eye fish has a transparent skull and eyes that point upward, gazing through its own head to watch for prey silhouetted against the faint glow from above. The giant squid, rarely seen alive, prowls these depths with eyes the size of dinner plates, the largest eyes in the animal kingdom. Each is a perfect mirror, tuned to capture the faintest traces of bioluminescence in the endless night. By 6,000 meters, we enter the Hadal zone. The word comes from Hades, the underworld of Greek mythology, and it is fitting. These are the trenches, the deepest parts of the ocean where pressure rises beyond comprehension. At this depth, every square inch of your body would feel the weight of a car pressing down on it. It is here, in the darkness and silence, that life has taken its strangest forms. The seafloor is covered with fine, pale sediment, disturbed only by the slow movements of scavengers. Giant amphipods crawl across the mud, shrimp-like but grotesquely enlarged, their translucent bodies glowing faintly in the submersible light. Sea pigs, bizarre relatives of sea cucumbers, wander the plains on stilt-like legs, using antennae-like appendages to sense the seafloor for morsels of food. These scavengers survive on the rare organic matter that drifts down from above. Tiny scraps of plankton, fragments of jellyfish, or the occasional whale carcass. A rare feast that can sustain entire communities for decades. But not all life in the trench relies on food from the surface. Around hydrothermal vents and volcanic seeps, colonies of microbes thrive by consuming chemical energy instead of sunlight. They use hydrogen, methane, and sulfur erupting from the seafloor as fuel, powering their existence in a world utterly removed from the sun. These microbes form mats on rocks and sediments, and in turn, they become food for other creatures. Here, life is built not on light, but on chemistry. One of the most extraordinary discoveries of recent years is the Mariana snailfish, found at depths greater than 8,000 meters. Delicate, translucent, and ribbon-like, these fish drift effortlessly through the crushing black. Their bones are soft, almost cartilage-like, preventing them from shattering under pressure. Their cells are filled with special compounds that keep proteins stable when the pressure should warp them beyond use. To see such a fragile-looking animal thriving in a world that would crush steel is one of the great paradoxes of the deep. Even stranger are the xenophyophores, single-celled organisms the size of dinner plates. To find a single cell grown to such a monstrous size seems impossible, yet here they are, scattered across the seafloor like pale, gelatinous sponges. Each one is a living fortress, packed with grains of sand and debris, built to withstand the crushing pressure. They are among the largest single cells on Earth, proof that life here rewrites the rules we thought we understood. Exploring this world is as dangerous as it is difficult. Machines and vessels not built with perfection fail spectacularly. In 2014, an unmanned deep-sea vehicle called Nereus descended into the Kermadec Trench near New Zealand. At a depth of nearly 10,000 meters, it suffered a catastrophic implosion. In an instant, the craft was destroyed, obliterated by the enormous force of the water around it. The lesson was clear. In the deep ocean, there are no second chances. That is what makes the human descents into the Challenger Deep so extraordinary. The Trieste in 1960, James Cameron in 2012, Victor Vescovo in 2019, each pushed engineering to its limit, locking fragile human bodies inside spherical fortresses strong enough to resist 1,000 atmospheres. Inside, explorers describe an eerie silence, broken only by the groan of metal under strain and the faint hum of instruments. Their lights pierce only a few meters into the black. Beyond that, there is nothing but darkness and perhaps the glittering eye of something waiting just beyond the beam. The Challenger. Deep is not empty. It is alive. Amphipods swarm in the gloom. Strange, gelatinous creatures drift by, fragile and transparent. Microbes cling to the silt, metabolizing energy from the Earth itself. Each glimpse of life is fleeting, yet each is a reminder that no matter how hostile the environment, evolution finds a way. And yet, for all we know, there is far more that we do not. Imagine trying to understand the Grand Canyon by lowering a camera into one spot at night. That is our knowledge of the trench. We have visited it fewer than 30 times. We have mapped it only in fragments. The animals we have seen may be only the beginning. Somewhere in the black abyss may dwell creatures we have never imagined, adapted to pressures beyond anything else on Earth. The Mariana Trench remains one of the last true frontiers of exploration. Its depths are hostile, its creatures alien, its geology violent and strange. But for those few who have descended into its black heart, the experience is unforgettable. To sit in silence, nearly 11 kilometers beneath the waves, surrounded by darkness that has never seen the sun, is to glimpse a world as alien as any beyond the stars. The trench itself is more than a graveyard for old ocean floor. It is a factory of extremes, a place where Earth constantly rebuilds itself. The Pacific Plate, ancient and heavy, slides downward beneath the Philippine Plate, grinding into the mantle in an endless cycle of destruction and renewal. Along its slopes are mud volcanoes, some of them 50 kilometers wide, venting hydrogen gas into the black water. Others release liquid carbon dioxide, a bizarre phenomenon made possible only by the immense pressure that keeps the gas in liquid form. Still others contain pools of molten sulfur, bubbling cauldrons of yellow fire hidden in eternal night. These are not features you find in the open ocean. They are signatures of the trench, unique, dangerous, and alien. To descend into such a place is to enter another planet. The geology, the chemistry, the biology all exist in forms utterly foreign to the surface world. And yet, within this hostile crucible, life has carved out an existence. The trench is home to amphipods the size of a human hand, with stomachs that sometimes contain fragments of things carried from far above. It is home to delicate snailfish that drift like ghosts across the seafloor. It is home to xenophyophores, strange single-celled giants that would be unthinkable anywhere else. And it is home to colonies of microbes, clinging to rocks, weaving invisible webs of energy out of chemical reactions. Every descent into the trench has revealed something new. During Victor Vescovo's dives in the limiting factor, cameras filmed snailfish gliding across the sediment at depths never thought possible for vertebrates. Amphipods collected from these depths were found to have unusual compounds in their bodies, stabilizing their cells against crushing pressure. Microbial samples revealed entire communities thriving where energy seemed impossible to obtain. Even the sediments themselves tell a story, layered with centuries of geological history, a record of Earth written in silt. The trench is also a realm of deadly power. Pressure at the bottom exceeds 1,000 atmospheres. At that level, ordinary materials are crushed to powder. Steel bends, glass shatters. and electronics fail in silence. Even submarines built for war cannot descend beyond a fraction of that depth. When the Trieste went down in 1960, the bang that echoed through its hull was a reminder of how close they were to instant obliteration. One crack, one weakness in the steel, and the abyss would have swallowed them whole in a microsecond. To travel into the Mariana Trench is not just an expedition. It is a gamble against physics itself. And yet, in that hostile black, there is life. And where there is life, there is mystery. Consider the xenophyophores again. They are single cells, yet they grow to the size of a football, packing their cytoplasm with grains of sand and detritus to build structure. How can a single cell endure such conditions? How can it grow so large when the rules of biology suggest limits far smaller? And yet, there it is, thriving in the dark, a living contradiction. Consider also the snailfish. How can a vertebrate, fragile, soft, and complex, survive where pressure would crush bones to dust? The answer lies in subtle adaptations. Proteins shielded by special compounds, bones softened to prevent shattering, membranes tuned to stay fluid under extremes. Each of these organisms is a biological puzzle, proof that evolution can solve problems far stranger than those we face on the surface. The Mariana Trench is the deepest scar on the surface of our planet. It is a place of unimaginable pressure, alien geology, and creatures that defy biology itself. It is a realm that challenges our engineering, pushes our science, and stretches our imagination. And though we have only just begun to explore it, one truth is already clear. The trench is not empty. It is alive, it is strange, and it is waiting. This is the Challenger Deep, 10,900 meters beneath the surface of the Pacific Ocean, a place more alien than Mars, more hostile than the vacuum of space, and yet undeniably alive. Amphipods scurry across the seafloor, scavenging for scraps. Strange gelatinous creatures drift in the beams of light, vanishing into the black as quickly as they appear. Microbial mats cling stubbornly to rocks, invisible colonies turning raw chemistry into survival. Even here, where the pressure could crush steel like paper, evolution has found a foothold. The human presence in this place is fleeting. Walsh and Piccard remained on the bottom for just 20 minutes before beginning their ascent. Cameron stayed for a few hours, Vescovo for a handful of dives. In total, fewer than 30 people have gazed firsthand at this abyss, compared to the thousands who have stood on Everest's peak, or the dozen who walked on the moon. The deepest place on Earth is also one of the least known, and that is perhaps the greatest mystery of all. For every amphipod collected, for every snailfish filmed, for every xenophyophore cataloged, there may be hundreds of creatures we have never seen. Entire ecosystems may exist along trench walls, in fissures, or clustered around volcanic vents that no probe has ever reached. The ocean hides its secrets well, and the Mariana Trench is its most impenetrable vault. The trench is more than a geological feature. It is a crucible where biology, physics, and chemistry collide. It is proof that life is not fragile, but adaptable, capable of bending to forces that seem impossible to endure. It is a reminder that the boundaries of our knowledge are still small, and the universe of the unknown still immense. And perhaps, in those secrets, lies the next great discovery. Even after all the expeditions, all the samples, and all the glimpses into that abyssal world, the truth is simple. The Mariana Trench remains almost entirely unknown. Less than 1% of it has been directly observed, and what we have seen suggests that each dive, each probe, reveals something new. A new creature, a new formation, a new question. Consider the amphipods once more, crawling across the seafloor like restless sentinels. Inside their stomachs, scientists have found the unexpected. Fragments of materials that should never be here. Traces of substances carried from far above, carried down through kilometers of water, and ending up inside the bodies of creatures that live 11 kilometers beneath the waves. The trench, though remote, is connected to the world above in ways we are only beginning to grasp. Then there are the strange geological marvels. Pools of molten sulfur that bubble and hiss in darkness, glowing yellow beneath the beams of submersibles. Mud volcanoes rising like colossal towers, releasing streams of hydrogen into the black. Seep zones where liquid carbon dioxide wells up from the crust, held in place by pressure so immense that gas is forced to become fluid. Each of these features is not just a curiosity, but a window into processes that shape the planet itself. The trench is not a static place. It is alive with movement, with chemistry, with tectonic forces grinding on scales of millions of years. So what lies at the bottom of the Mariana Trench? The answer is both simple and infinite. Life in forms as strange as dreams, forces as violent as creation itself, pressure, darkness, silence, and above all, mystery. A mystery carved into the crust of the earth, waiting in the black for the few bold enough to descend. Perhaps that is the final truth of the trench. It is not just a physical place. It is a challenge, a riddle, a reminder that even on our own planet, there are worlds as alien as any beyond the stars. And as long as that trench remains, silent and waiting beneath the Pacific, it will call to those who dream of frontiers. For in its darkness, in its pressure, in its impossible depths, the Mariana Trench is proof that there are still places on Earth where the map ends and the unknown begins.